there being two main kinds of minerals: silicate minerals and non-silicate minerals. And I mentioned that silicate minerals are 90% of the minerals that are in the Earth's crust. The other 10% are non-silicate minerals. Even though non-silicate minerals are only 10% of the Earth's crust, they are absolutely important to us, to civilization itself, because many of them are valuable ore minerals, O-R-E. What is an ore mineral? An ore mineral is a mineral that can be mined for a profit. You might go online and see some people talk about ore minerals being metals that can be mined for a profit. That's the old definition. The new definition is all minerals that can be mined for a profit are ore minerals. I mentioned before that silicate minerals have silica and oxygen in them, so you should be able to identify them based on their chemical composition. Any mineral that has Si and O in it, such as quartz, has Si and O in it, is going to be a silicate mineral. Non-silicate minerals. Let's talk about those now. There are 1, 2, 3, 4, 5, 6, 7 kinds you need to be able to you need to know about. The first is called carbonate minerals. Then we have oxides. Then we have native elements. Then we have sulfates. We have sulfides. We have fluorides, and we have phosphates. We're going to talk about them one at a time. First one we're going to talk about is the carbonates. And the carbonates are the most common of your non-silicate minerals. Here is a carbonate mineral right here. Calcite, CaCO3. In chemistry, CO3, 3 oxygen atoms bonded to a carbon atom, that molecule is called carbonate. Any mineral that has CO3 in it is a carbonate mineral. On this coming test, fair warning, there's going to be chemical formulas, and you need to figure out, is it a silicate mineral, is it a carbonate, is it an oxide, what kind of mineral is it? Well, if it's got CO3 in it, like calcite, or this other mineral called dolomite has CO3 in it, it's a carbonate mineral. Carbonate minerals will react to acid. Calcite will react very quickly and strongly, and dolomite a bit more weak. Calcite's very important in making cement. Next type of non-silicate mineral we want to talk about is an oxide, O-X-I-D-E. An oxide mineral is any mineral where a metal is bonded to oxygen. Fe is iron. Iron oxide, that's what we call rust or hematite. Fe3O4 is another oxide mineral. You could have copper oxide. You could have silver oxide. Anything with a metal bonded to oxygen is an oxide mineral. A lot of them are used to make metals. Iron, aluminum, tin, etc. Third type of mineral we want to learn about is a native element. A native element is a mineral that's it's just one element all by itself, such as diamond, which is carbon, C. Graphite's also carbon. Or gold, Au. If it's just one element, or sulfur, S. One element all by its lonesome, not bonded to any other elements or compounds, it is a native element. Obviously, diamonds are very expensive. Gold, platinum, sulfur, they all have economic uses, so they are ore deposits. Copper, used in wiring. Gold is a way to store wealth. Diamonds are very expensive, both for jewelry and for diamond edge drill bits. Sulfates. Let's talk about the sulfates. The sulfates are minerals that have this molecule in it, sulfur bonded to 4 oxygen atoms, SO4. If it's got SO4 in it, it's a sulfate mineral. Here's another sulfate mineral. It's got SO4 in it. Probably the most important sulfate ore mineral is gypsum, GYPSUM. You had it in your lab. You could scratch it with your fingernail. It's softer than your fingernail, so it's less than 2.5 in hardness. It's used to make drywall. Very important to our economy. Sulfates. Sulfides are when you have metals bonded to sulfur atoms, such as galena, lead sulfide, cinnabar, silver sulfide. Notice the difference between a sulfate and a sulfide. Sulfates have SO4 in it, and sulfides have sulfur bonded to a metal. Next one we're going to learn about are the fluorides. The fluorides are also called the halides. Let's just use the term halides. I should have used that. Okay, halides. So scratch fluorides, halides. Anyway, what are the halides? Halides are minerals that have chlorine, fluorine, or bromine in it. So if a halide has either Cl in it, Br in it, or F, fluorine in it. Here's some halides. Sodium chloride, also called halite. You might remember this mineral had 3 directions of cleavage, a hardness of 4, non-metallic luster. Sylvite, potassium chloride, used in fertilizer. We also have another common halide mineral is CaF2, otherwise known as fluorite, used in toothpaste. If it's got Br in it, Cl in it, or Br, Cl, or F in it, it is a fluorite. It is a halide mineral. Last one is a phosphate mineral. And a phosphate mineral has a molecule PO4 in it, such as apatite. Apatite has PO4 in it. PO4 is phosphate in chemistry. SO4 is sulfate. So this is apatite's very important because that's what our bones are made of. If it wasn't for the apatite mineral, no vertebrate organisms could survive because we need this mineral. We need to eat it through whatever we're eating so to build up our bones. Phosphates. So on the test there's going to be chemical formulas and you have to figure out what type of non-silicate mineral or silicate mineral you're looking at. Here's a common carbonate mineral called calcite. You saw it in lab. Good cleavage. Look at that, how it breaks in a predictable way. Translucent, light passes through it. You could drop acid on it and it'll react with acid used to make cement and concrete. It's a nice ore deposit. Oxides, halides, sulfides, we talked about those. Here's hematite, Fe2O3. What type of non-silicate mineral is that? That is an oxide mineral. How about Al2O3? Metal bonded oxygen. It's another oxide mineral. Halides, halide minerals, once again, contain Cl, F, or Br in it. Most common one is halite. We put in our eggs every morning. We use it to melt snow. It's a very common non-metallic mineral. Pyrite, Fes2. It's a sulfide mineral. Back in the old days, in the 1840s, they used to call it fool's gold because it kind of looks like gold. Sulfate minerals, gypsum, important ore mineral. Georgia Pacific, the company my son works for, they ship lots of drywall all around the country. It's required in making drywall. If it's got SO4 in it, it's sulfate mineral. Phosphate minerals contain PO4. Native elements are just elements all by themselves, such as gold and sulfur. When you're identifying minerals, when you pick up that mineral, how are you going to know what mineral is it? First thing you have to do is figure out its luster. Is it metallic or non-metallic? Metals are usually shiny, but not always shiny. What attributes do metals have? Well, they are opaque. That means light will not pass through them. They're usually not too light, but when you rub it against a porcelain plate, it'll give you a dark colored streak. Sometimes, if it's magnetic, it's definitely a metallic luster. And you can never break a metal with your fingers, so it can't be weak. So if it fits all those criteria, you could say it has a metallic luster. Otherwise, it has a non-metallic luster. The other thing you can use is the color of the mineral, but I'd be real careful about doing that because some minerals come in many different colors. That's why just taking photographs of the minerals is not going to help you get things right on tests, because the same mineral can come in different colors. So much more reliable than color is streak. A mineral will always have the same colored streak. It always have the same luster or the same hardness. If it grows into crystals, you can use that to identify minerals. For example, quartz. Quartz. If you get quartz, and it grows into a crystal and into the crystals, you can tell because quartz always grows into six-sided crystals. Doesn't matter what color it is. If it's orange, it's called citrine. If it's purple, it's amethyst. If it's gray, it's smoky quartz. But if it's clear like this, they'll always have six sides. So garnet is always gonna, if it does grow into a crystal large enough to see, you can always identify it because it grows into 12-sided crystals. It's what we call a dodecahedron, like these. 12 sides. So if it grows into crystals, sometimes the crystals are too small. You can't use crystals, the crystal shape. But if it does, you can use crystal shape to identify them. But most important is cleavage. And mineral cleavage, that's the way the mineral breaks. If the mineral breaks in a predictable way, if you hit this mineral here with a ball peen hammer, it would break in a predictable way. It'll break right here. You can see the planes of weakness, which are flat. This happens to be halide. Well, halide, which always has three directions of cleavage. If it has one direction of cleavage, then it will make one direction of mineral cleavage. And the mineral will break off in sheets, like biotite. That has a non-metallic luster. You can break it with your fingers, by the way. Or muscovite, which, let me show you muscovite. Muscovite looks like this. It's called a mica. It breaks off in flat sheets. It has one direction of cleavage. So cleavage and hardness are really useful in identifying minerals. Streak is also very important when you're dealing with metallic minerals. Those things will always be the same, whereas color is not as reliable. There are certain minerals that only come in one color, such as sulfur, which is always canary yellow, or olivine, which is a greenish color. But these other ones are more useful. You'll get dark colored streak plates and light colored streak plates. Light colored streak plates give you minerals with a dark colored streak, and they show up well in the white. Dark colored streak plates are better for minerals that give you a lighter colored streak. Hardness. When a geologist asks you how hard is a mineral, you give them a number between 1 and 10. And then you use all of these common tools. Your fingernail. If you could scratch a mineral with your fingernail, it's a hardness less than 2.5. If you scratch it with a penny, it's a hardness of less than 3.5. If you can't scratch a mineral with a knife, if you cannot scratch it, then it has a hardness of more than 5.5. So you use these different tools and try and figure out what the hardness is. That's another useful thing to know. And then you put it all together: color, cleavage, hardness. Oh, by the way, if a mineral does not have cleavage, it fractures, like this mineral here called citrine, which is a form of quartz. This does not break in a predictable way. Therefore, it does not have cleavage. It doesn't have flat planes of weakness in it. Does this mineral here have cleavage? Yes. See how it breaks in these flat planes? You can see it under a microscope. You can see the cleavage quite well. Specific gravity means that the mineral has it feels heavy for its weight, like galena. That's it, ladies and gentlemen. Please get ready for the next test. Now, talk to you later.